acquire the disease. Each year we're revising upward this number. It's conceivable that all infected individuals will ultimately develop clinical disease. 270,000 cases of AIDS will be diagnosed and reported by the end of 1991, with 74,000 cases in 1991 alone. And the direct medical costs, of course, are enormous. I think we will all be challenged to, those of us who are of scientific bent, to apply our creativity to dealing with this problem, and to those who have other talents, to think about ways of dealing with the enormous social and human toll that this takes. And the toll is enormous without adding social ostracization, I think I learned, socially ostracizing patients. We have no evidence that casual contact can transmit this disease, and so while we must devote a lot of energy to curtailing the number of new infections, I don't believe that we are at risk from coexisting with AIDS patients. Thank you. You have some questions? Yes.
Yes, in the case of hypertension,
Mm-hmm.
why would it be a function of volume? So how would it be?
Okay, the critical question is what constitutes an infectious dose? In people, we don't know. In fact, it may be different depending upon the virus. Viruses may differ in virulence. But for purposes of discussion, let's say that one infected lymphocyte can do it. That's the conservative way of looking at it. Okay, how many lymphocytes does an AIDS patient have? Somewhere between 1.5 and 2.5 million. The next question is how many of those lymphocytes are infected? There's a range depending upon the individual and the stage of their disease. It can range from 1 in 1,000 to 1 in a million. Most people, for purposes of calculations, pick around 1 in 50,000. So, in a whole milliliter, 5 milliliters in a teaspoonful, this is a large volume of blood, a milliliter, and approximately 1 in 50,000 could be infected. You can see that you're not going to have very many infectious units, infectious doses in a milliliter. Now, the volume issue comes up. How much blood can you have adhere to the mouth parts of an insect? That volume is so small that if you make the kind of calculation I just described, you get a number of about 33,000 mosquito bites required to transmit one infected lymphocyte. You do the same experiment, or calculation I should say, with bedbug, it comes out to about 4,600 bedbug bites to have a high mathematical probability of transmitting one infected lymphocyte. Now, these are numbers games that are instructive. They're not proof positive. If you happen to get, the bad roll of the dice where the first one has an infectious dose, you could conceivably become infected. But we're not talking about 1 or 2 bites. I think that further epidemiological studies ought to be done in Africa, where there are, for example, fishermen who may sustain 150,000 mosquito bites in a year. This is the population where you might reasonably expect to detect a very rare event. Also, the epidemiology may change with time as we have more individuals infected. So I think we should still look, but in the whole priority of AIDS research, I consider this quite low. Yes?
Doing that same kind of calculation, the volume of blood on the mouth parts and the number of infected lymphocytes, how many needle sticks does it take to logically transmit AIDS?
Well, I think you can analyze the data directly, which is that on any given needle stick, you have 3 chances in 1,000 of seroconverting. 0.3% is what's come out both in this study I showed you with 800 and some people, and now it's been extended to 1,200. And if you simply extrapolate downward in volume, take 1 microliter as the mean size of a needle stick, and go down to 70 nanoliters on a bed bug and 5 or so nanoliters on a mosquito, you get the same kind of numbers as you do from calculations of viremias and levels of infected lymphocytes. So they're within the same ballpark, depending either way you calculate it.
Yes, I read about a year and a half ago in the press about the possibility that the mosquito would be testing in the primate population, I think chimpanzees, to see if there was any.
Okay, I think this experiment, to my knowledge, has not been done. The proposal is to take the simian virus, simian immunodeficiency virus, and artificially feed those mosquitoes, artificially feed mosquitoes the simian virus, and then let them feed a chimpanzee. I think the reason that it has not been done is that there is an enormous need to do primate research on projects that people feel will have a more immediate public health impact, and I think it's just too far down the list that hasn't been done. Chimps are an endangered species, and those that are raised in captivity are being used for experiments. I think somewhere down the line that experiment should be done. The simian virus is not identical to the human virus, so it won't be an absolute demonstration of the question of interest. Mm-hmm.
Yeah, one of the things about the retrovirus that I've read is that it's highly mutable. Has there been any historical precedent for a virus changing its mode of transmission due to mutation in the virus after contraction?
You're correct, it is highly mutable. It's been estimated that this virus mutates at 3 to 4 times the rate of flu virus. You know how long a flu vaccine lasts. The question of whether mutation could result in an alternate mode of transmission, I don't know of any precedent for it. Intuitively, I find it highly unlikely. There are certain mutations that could render a virus capable of more readily replicating in cells, but to radically change so that it can use the reproductive machinery of a radically different cell type is not simply tweaking the molecule a little bit here and there. It would be some major accretions of functions that the virus didn't have originally. I would think that would be highly unlikely, but in fact, I don't know.